This is the very simple questions which is included in UGC CSIR exam. What they ask, H1 NMR spectrum of the mixture of benzene and acetonitrile shows two singlets of equal integration. The molar ratio of benzene and acetonitrile is, and these are the four options. So how do you calculate? Benzene, acetonitrile structure, I guess everybody knows. Benzene contains the 6 protons, acetonitrile contains the 3 protons. Integration is 1:1. So how do you calculate? Anything? I already said it's a discussion type of thing. I'm not, you already know this NMR. Yeah. So what you will do? You will find out the ratio of under the each integration, how many protons are there? Benzene, the integration, suppose it's 12:12. I'm taking just one arbitrary figure. Integration per hydrogen, how do you find out? For benzene it's a 6, for acetonitrile will be 3, so it's a 2:4. So your molar ratio become 1:2. So the option 3 is correct. So the small problems you have to take during the lectures. Okay, so what we do, the first step for the interpretation of any NMR, it can be H1 or C13, you will try to calculate the number of signals in H1 and carbon 13. The number of signal is equal to number of different kind of hydrogen. Similarly, you can apply for the 13C NMR, number of signals for the is equal to number of different types of carbon present in a molecule. So this is the example of 4-methyl benzaldehyde, 1, 2, 3, 4. So 4 kind of hydrogen are there. So the first step, you ask the student to find out the chemically equivalent or chemically non-equivalent protons. So let's do chemical equivalent. All these compounds contain only a single type of protons or hydrogens. Let's see here. The first example is ethyl chloride, 2 kind of hydrogen, diethyl ether, 2 kind of hydrogen, and ethanol, 2 kind. So it's a 3 kind of. So what is mean by the chemical equivalent proton? They should have the same chemical environment. The chemical shift of this chemically equivalent proton will be the same. Of course, they will not couple with each other. Chemical equivalent protons will not couple with each other. And how do you identify? You replace each of the hydrogen and by another phantom atom and try to get another isomer to correlate with your original isomer and the new isomer. Let's do the same exercise with this molecule. How many kinds of proton are there? First one is ethyl chloride, simple, 2. Next, chlorobromo, bromochloroethane, 2. 1, 2, 3, 3. These protons are labeled as HA and HB. So you just replace HA with any phantom atom. You already have a symmetric or chiral center in your molecule. So when you replace any one proton, you will get a different isomer. So this total signal will be 1, 2, 3 and 4. Next. Sure? Not 2? All are olefinic proton, they will come at the same. So total, please find out, please ask any student whenever it will be there, some structure will be there, find out the non-equivalent protons. Next, the protons that have the same chemical environments are called as chemically equivalent and they have the same chemical shift. The 2 nuclei that are interchanged by the symmetry operation or rapid mechanisms, you should consider this symmetry operation. One example let me give here. This is the propane structure. How many types of protons? 2 types. Next. Only 2? Which are these 2? 2 blacks, they are same because what you have done, why they are same? Because you are apply a symmetry, some symmetry operation you have done. this axis which is going through the bromine, carbon, carbon, this carbon will divide whole molecule into 2 equal half, and then these 2 protons become equivalent protons. So let's look at some new concept. It's not new, magnetic equivalence and non-equivalence. When the 2 nuclei have the identical relationship with the same identical partner, they are magnetic equivalent. I will again highlight again the 2 nuclei with the which we call as a magnetically equivalent. They should have the same chemical shift. They should have the same coupling constant, but with same partners. Please underline. The magnetic equivalent proton should have the same coupling constant with the same partner. Example I will give here. Here it's a 1, 2, 3 dibromobenzene. Let's look at these protons. How many chemically non-equivalent protons are there? H1 and H3, they came at the same position, while H2 will come. Let's look at the coupling constant. H1 will couple with H2 with orthocoupling constant, which is normally 8 Hertz. H3 will also couple with H2 with the same coupling constant, right? The coupling constant now are same, and their coupling nuclei is also same. So H1 and H3, they are called as a magnetically equivalent nuclei. Let's look at this other. This is just bromobenzene we have done. How many kind of different chemically non-equivalent protons? How do 3? H1, H5, they will be same, H2, H4, H3. So total you will get the 3 sets of chemically non-equivalent proton. Let's look at the chemically non-equivalence. H1 will couple with H2, orthocoupling constant. H1 will also couple with H3, which is a metacoupling constant, which is usually 2 Hertz. H5 couple with H4, 8 Hertz coupling constant. H5 couple with H3 with a 2. Now, as you are saying that H1, H5 they are same, H2, H4 they are same, let me know the coupling constant between H5, H2, H1 and H4. They are para coupling constant. Yeah, okay. For this case, the para coupling constant is very less, you are not observing, but I will take some other example as well. The point I would like to highlight over here, H1, H5, they are chemically equivalent, but H1 will have the orthocoupling with this, but H1 and H4, they have the 1,4 coupling or a para coupling. So the coupling constant is different. H1 will couple with H2 with the 8 Hertz coupling constant, H1 will couple with the H4 with the para coupling constant, isn't it? So the coupling constant become different. Same thing is H5 couple with H4 orthocoupling constant, H5 couple with H2 with the para coupling constant. So the coupling constant is now different. So they are magnetically non-equivalent protons.